actually have read. Let's get good at that. Do that. Just check that it's actually working. Cool. Do you want to full screen your thingy?
Oh, sure. Present mode. See if this works.
Cool. So welcome along to the Wellington OWASP meetup. Nice to see some new faces. We always want to encourage developers and web developers and other people to come along, so it's great that you can make it. We aim to meet every 2 months or so with some pizza and a talk. So the next one should be in whatever's 2 months from now, July-ish. I'd like to introduce Felix, our speaker today. Felix works at Xero. He's on the security team, helps defend their applications from attack, often his own attack. He did a talk similar to this one at the OWASP conference in Auckland, which is the Developer's Guide to Cross-Site Scripting, and I asked him if he could do it at our meetup as well. So let's give Felix a clap.
Well, thank you very much, Kirk, for the kind intro. Let's talk about cross-site scripting. Most of you are here because you're here for the pizza, right? Or the talk. One of those two. All right, let's get started. Obligatory who am I slide. My name is Felix Shi. I'm a security guy at Xero. What I do for hobby, and a gentle disclaimer, something about my own opinion does not reflect those of my employer. You can't see it, but I said it. So, whatever I say is my own personal opinion. Future disclaimer, this is a primer to cross-site scripting. By no means it is an exhaustive list. Don't use it as a complete reference material. Please consult your local security team or physicians if you think you're suffering from cross-site scripting. All right, now we got that boring stuff out of the way. Let's talk about what we're going to talk about today. So there's 2 sections to this talk. First of all, let's talk about the background. What exactly is this issue? Why is it an issue? What does it affect? Why should you care? And the year is 2017. Why is it still an issue? And then we can talk about how can we exploit it as an attacker, of course. After that, there'll be some demos. I've created a few vulnerable web applications, and we'll see how we can actually attack those web apps using cross-site scripting. After that, we can see how do you prevent it from a developer's perspective. How do you actually prevent other baddies from doing the same thing to your web apps? And then Q&As. Let's get started. Background. So, web app devs. Most of you in the background. Let's talk about web applications. So, modern web apps normally consist of 3 parts. The stuff that gets sent to the browser, like the things that get rendered by the end user, for example, HTML, JavaScript, CSS, style sheets, or pretty pictures, the things that get sent to the user. The stuff that the user doesn't get sent to the user, like server-side stuff, whatever server-side languages you use, say Ruby on Rails or Python, C#, .NET, etc. Those things never get sent to the user. They are all handled on the server side. And then you have things that are stored in the server, like stuff in the cloud or SQL database or file storage. Let's talk about HTML. Show of hands if people have actually worked with HTML in the past. Hey, most people have. That's good. So HTML's been around since forever. Correction, invented in the late 80s. It is the building block of the web, and let's have a quick overview of how things on the page are rendered by HTML. Tags, HTML tags, spiky brackets. Things inside the spiky brackets describe how things should be rendered on the page, like the B tag, this bold, U tag, underline, the image tag normally just says, all right, display an image on the page. Quick primer. So for example, bold text, underlined, and some kind of leaning tower. Now, after we talked about HTML, how do you put JavaScript on the page? So JavaScript was invented in, I think it's like mid-90s to be precise, 1995, 96, don't quote me on this, by some smart cookie from Netscape to add interactions to the page. For example, you can include JavaScript on the page using script tags, like open script tags, and you can just write out your JavaScript in there, like console.log hello would actually display the text hello in your browser's console. JavaScript source, you can include external JavaScript files into your page. For example, you can put all your JavaScript into one file and then include it in your page. People are nodding in the back. That is good. People are saying, yep, he's not talking crap. And the last one is you can include what's called an event handler on an existing resource. For example, in this case, if you're loading an image, once the image is loaded, run some JavaScript. There's some other event handler as well. For example, in this case, it is on load. There could either be stuff like on error. If the image doesn't load or there's an error, run this JavaScript. Or on mouse over. When someone flops their mouse over an image, it runs some JavaScript. Sure, in the past you have seen stuff on a page where it displays one image, when you float your mouse over it, it displays something else. And that's all handled by JavaScript. So this is important. Let's talk about JavaScript. What's next? So what can you do with JavaScript? These days, modern web apps are pretty much full of JavaScript, especially the new, what is this new thing called again? Like single page apps or whatever. Like this, perhaps the cool kids are now all designing single page apps with stateless whatever. So most of it's made of JavaScript. What can JavaScript do? You can alter the look and functionality of the page. Using JavaScript, you can modify what's called a DOM element on the page. What's being displayed to the user. You can actually change it using JavaScript. You can access private user data associated with the site. Because HTTP is a stateless protocol, there's a thing called cookie, which keeps track of the user's logged-in session and what's not. JavaScript can access cookies, generally, or local storage. You can perform actions on the user's behalf. Some people are looking contemplative. Using JavaScript, you can do stuff like, say, you can submit forms without the user's knowledge, like make AJAX calls and what's not. Feel free to ask any questions. By the way, you're looking confused. Or just going, that's not right. All good?
Yeah.
Cool. All right, but you're like, but I trust web apps I use. I trust JavaScript. All right, now let's talk about cross-site scripting. So what exactly is cross-site scripting? It's when someone can actually run their own JavaScript stuff in the context of your own site, of your site. For example, you can run say www.myown-site.com. But if someone else can run JavaScript on your domain, then you have an issue. You're like, why is it an issue? Okay, so let's talk about what people can do with JavaScript. So with JavaScript, you can alter the look and functionality of the page. If a malicious user is able to inject arbitrary JavaScript onto your page, they can, hey, look, the three things we just mentioned before, alter the look and functionality of the page. They can display a rude image, for example. They can actually deface a site using JavaScript. Alternatively, they can actually access private user data associated with the site, like steal the user's cookies, impersonate a user, etc. And last but not least, they can perform actions on the user. For example, if a user accesses your site and it is running JavaScript written by a malicious actor, they may be able to, the rogue JavaScript might say to the user, all right, change the display picture and then change their password, for example, thus giving the attacker access to the victim's account. And you're like, oh, I don't really care. I'm just a dev. Like, I don't actually, I don't get paid to do security stuff. Some people might be like that. But how could it affect your company? Well, especially in the world of cloud, loss of trust is a major issue. For example, bad PR, it's going to take forever to recover from, especially in the world of social media. Once it gets on Twitter, it's going to spread like wildfire. And also, any product owners or agile people around? No? Oh, good. Okay, cool. So fixing technical debt is expensive, which leads to angry product owners. And generally, something's late, something dark side. Like fixing technical debt or actually trying to bootstrap security onto a finished product is to be a dev, a disgruntled dev, and I used to do that, and it's not enjoyable. Last but not least are regulation and compliance issues. In order to operate in certain jurisdictions, you need you can meet certain compliance requirements, like say, PCI, DSS, ISO, insert number here, for example. And some of them requires a clean pen test report to be presented, and that can be difficult if you have cross-site scripting in your website, because pen testers will find that. So you might ask, why is that still an issue? This thing's been around. JavaScript's been around for 20 years. The web's been around for a long time. Why is it still an issue? Surely it's a solved issue now. Because ultimately, handling user-defined data is difficult. Let's talk about exploitation. All right, so let's talk about how, if you're a bad person, or if you're a pen tester, I'm not saying pen testers are bad people, but I'm just saying, like, if you're out there looking for issues, how are you going to find them? First of all, try to figure out where user can supply data in your page. Common areas are generally input fields, like text fields, URL parameters, other pretty much form input fields. Find out where the user data gets submitted, and then see where the data gets used on a page. So ultimately, the goal of cross-site scripting is to get the browser to execute whatever JavaScript you run. So let's talk about this. It wouldn't be a cross-site scripting talk if we don't talk about the different types of cross-site scripting, because that's like, there are multiple types of cross-site scripting. I know a lot of people get a bit hung up on the definitions of them. Let's just have a quick run through of what they are and how you can test for them instead of actually drilling too deep into the definitions. So the first type, most people call it reflected, is where you have your payload or just a malicious script inside a URL. A URL parameter, for example, in this case, you have a trusted site slash search.php a parameter called Q, and then you have the user provided that data here. And that actually gets, when the user visits that URL, this gets just chucked onto the page. Like, for example, something like, hey, look, you searched for blah. How would an attacker exploit that? Well, they have to actually copy that URL, send it to someone, or get someone to visit the URL via either, say, phishing or social engineering or what's not. You need to get them to actually access that URL in order for the payload to trigger. You're good there.
Just testing the YouTube work, sorry.
Okay.
Not about volume.
Yep. And the next type they call it is generally, it's called a stored cross-site scripting. This is where you actually have the payload stored in a database somewhere. And every time that value in the database gets rendered on the page, and someone visits the page where the payload gets used, the payload gets triggered. For example, username, or something like, let's say, hypothetically speaking, you're running an online auction site. Perhaps your item description or your item name, and that gets stored in the database somewhere. And when people visit, the page where your item gets loaded, the JavaScript gets ran. So generally, they're considered a lot more dangerous than reflected cross-site scripting, mainly because you can actually prepare them in advance. And it's sometimes a lot more people instead of actually a targeted attack. Anyone that uses that service and visits the page can get affected. And last but not least, there's one last type, it's called DOM-based cross-site scripting. And for web developers, in this case, you have the payload that's somewhere in there, but it never gets used in the page's source. So somewhere in the page's source, it grabs the payload and constructs a page DOM element from it. You source page, but somehow it still gets used in the page. That we will show that in a demo very soon. So everyone likes a good demo. Hope, fingers crossed. Hope it works. Let's talk about guestbooks. How many have actually seen a guestbook before? Wow, this is like the early 2000s all over again. All right, please sign my guestbook. So, what's my name? My name is Felix. Message, I love this guestbook. If I can spell, I love this guestbook. So, it submits this query to a guestbook, and it goes, thank you for signing my fancy guestbook. And then you can see previous guestbook entries. Life is good. So if you were to say threat model this thing, where's the user provided input fields?
The two input fields, right?
Yep, so you have username, name, and the message. And then there we go, it gets chucked onto the bottom. But can you see the URL here? So it's like localhost 5,000 entries, title equals fancy guestbook. So URL parameters is another thing that the user can tamper with. So if I actually change that to not so fancy guestbook. Thank you for signing my not so fancy guestbook. Let's see if we can actually chuck something else in, like, as we described earlier, HTML tags. Thank you for signing my underscore not so fancy guestbook. Can we put something else in there? I think a lot of the web developers in the audience will be familiar with this thing, script alert 1. Most people will be like, what is cross-site scripting? Chances are people's like, it's a bloody alert box. I mean, the thing is, your security team, if they actually show you script alert 1, that is a way for them to tell you, hey, I can run JavaScript without actually creating a convoluted payload. It is a proof of concept. By no means is that the extent of what people can actually do with cross-site scripting. So in this case, that actually broke the page. It says, yep, thank you for signing my, if you inspect the source code, you see that when it loads, there you go, like, thank you for signing my, and then the script tag gets inserted into the page and the alert JavaScript gets ran in the background. So what can a bad person do?
Redirect to another URL.
Let's do that. Let's redirect to another URL. So let's change the title to, I happen to have this prepared earlier. There we go. So title is script window.location.replace, which changes the URL to something else, and then to something I prepared earlier, which is called proof of concept login. Let's copy and paste that. What happens when the page loads? Thank you for signing my, oh, look, I have to sign in with my organizational account. Felix@felix.com. Password.
Cool domain name.
I know, right? Sign in. It's like, oh no, you got fished. So in this case, in order to exploit that, you need to provide that URL, or an attacker needs to provide the URL to someone, get them to click on it. In that case, let's see what else is there. Alternatively, there is another payload I prepared earlier, which is this. So proof of concept.javascript. Because when you click the submit button in this page, and hold up one moment, in this page, it makes a post request to an endpoint of the server where it posts the username and the message. What if there's a piece of JavaScript that just goes, we'll take the submit endpoint, we will fill out the form on behalf of the user, like for example, in this case, it's called totally legit user, and the message is, this message was submitted without my knowledge, angry face, and then submits it with JavaScript. Let's see if that works. So, raw payload. I'll just grab the URL encoded one because I'm lazy. So that is actually what the payload looks like normally. So you have a script, load a source somewhere, and then include the external JavaScript into your request. But because we're putting it inside a URL, you need to do a thing called URL encoding because it contains special characters. So let's try that. Let's see what happens if I just paste that in here. Thank you for signing my, oh, looks like something broke. Let's go back and refresh the guestbook. If we scroll to the bottom, you see the message got posted. So in this context, the damage is rather minimal. But imagine in a real, let's say, a real environment where there's multiple users and users have access to, say, confidential information, among other things. If a malicious user can make the user do stuff without their knowledge, I mean, it all comes down to business logic, like what can they actually do without their knowledge. So right now, what we demonstrated is that we demonstrated what's called a reflected cross-site scripting attack. because all we've done is that we just messed with the URL parameters. What if we actually store something on the page, as in every time the page loads, it gets ran? So that's generally a lot more annoying and destructive. So in this case, if we just go say script, the same payload, which is redirect the user to a fake login screen. So in this case, the message is just script window.location.replace takes them to the fake login screen. But the difference here is that this script gets stored in the server-side backend, and whenever people sign the guest book, the script will get run. So it goes, right, it takes you to the page. But if I actually want to go back to the guest book, like if anyone signs it, like say Felix 2, test 2, it gets redirected there. So now, unless the end user disables JavaScript, there's no way for a normal user to view the other guestbook entries. Like, because every time they visit it, they just get redirected to this page. Kind of annoying. And I think I can't demo anything now. I can't demo anything here now because every time I submit something, it just redirects me to this. Hence, earlier, as mentioned, stored cross-site scripting can be kind of scary. And that was the case with the MySpace worm a while back. Well, by a while back, I mean like a few, how many, 10 years, 15 years ago? A while back. So MySpace is like, to the youngins in the room, it's like Facebook, before Facebook. Back in the, like, it's like your granddad's social media network, where there was a cross-site scripting issue, and if I recall correctly, the status, user status can update, like how are you feeling today? I'm feeling great, I'm feeling wonderful, what are you doing today? That part is vulnerable. So some smart guy by the name Sammy Kamkar decided to post a piece of JavaScript in there. And what the piece of JavaScript does is that it changes the status to Sammy is my hero, and then send a request to the server backend and add Sammy as their friend. And also copy and paste part of that JavaScript into their status as well. So anyone else visiting their page will have that JavaScript right on them. As you can imagine, by the nature of social media just spread like wildfire. And within 24 hours, the guy's got like 1 million invites or something. And MySpace has to go offline for a little bit to fix that. So yeah, in the age of social media, that's kind of scary. All right, so that's enough scaremongering and fire and brimstone. Let's talk about how you fix it. So cross-site scripting issues are generally introduced, let's sort of recap, when user-supplied JavaScript are executed by the browser. You might say, how does this happen? Well, generally it's when there's inappropriate handling of user-provided data. In our example, there's multiple user-defined data. For example, the title of the guest book. The user can change that to anything they want. The username, user can actually change that. And the message. That's the example we gave earlier. You put the standard proof of concept script alert 1 in there, and that gets executed by the page. How do you fix it? Well, don't allow user input. Done. Everyone go home. Life is good. Well, not really possible in real life. So the thing is, there's 2 ways of approaching it, and I'll just go through both methods, and I'll tell you which one I personally prefer. So for starters, you can ensure that the user-provided data is validated when appropriate. That can be very difficult when it comes to some fields, like for example, username. Especially now as we're moving towards internationalization and globalization. When you're doing input validation, people often take a whitelisted approach. Whitelisted series of characters, only allowing a certain set of characters to be present in this field. For example, if you're only whitelisting alphanumeric characters, what would happen if, let's say, someone with a Japanese surname shows up? They type in their Japanese last name in kanji. Because it is not an alphanumeric character, they're going to get an error message that says, you're not writing a real name there. And they'll be like, what is this? So often implementing the correct validation mechanism is very difficult. And also the last thing is, you can ensure that the user provided data is properly encoded or escaped on display. So you're like, what is encoding? Oh, yeah, I had fun just tilting the the text, give it, make it more dynamic, make it look fancier. So HTML encoding, there's different flavors of encoding. Let's first talk about HTML encoding. So HTML encoding is a technique that converts dodgy characters into characters that are safe to be displayed on the page. Like as we mentioned earlier, in order to create an HTML element, you need spiky brackets, like spiky brackets, and then you put stuff in there. And then close the spiky bracket. Like to display JavaScript, you need to go spiky bracket, script, close spiky bracket. What HTML encoding does is that it turns spiky brackets and some other characters into safe display format. So when you have spiky brackets, it just gets displayed literally as spiky brackets on the page, as opposed to getting it treated as control characters by, whatever HTML handler that's in the browser. So when you type in spiky bracket script, it's going to get rendered on the page as spiky bracket script. Instead of the browser going, oh, I know this. This is JavaScript. I'm going to execute it like a good browser. So in the example we gave earlier, you have script alert 1, and then on the other side, you have pretty much that will get executed by the browser as JavaScript. But on the right-hand side, it's just going to get displayed as. Oh, you can't actually see it down there. How do I hide this thing? Hide, please. So the user actually just sees this text displayed verbatim. So script alert 1 / script. Hence, no script execution.
So does that mean that if it's persisting, for example, that it persists as the input, or is it on the output when it comes like that?
Yep, so it really depends.
Do you want to repeat the question?
Sorry, would you mind repeating the question?
No,
you repeat it again.
No.
Would you mind repeating the question? Sorry.
Yeah, how is it persisted? Is it persisted like the input or the output on the database?
Oh, yep, so the question is it persistent on the input or output on the database? So it really depends on where you are doing the encoding. So generally, my personal preference is to do encoding as close to the presentation layer as possible. So try not to store encoded stuff in the database. You see why very, very soon in the next demo, if that's okay. There's multiple flavors and ways to do encoding, and sometimes you have to use different kinds of encoding based on what context it's used in. So there's HTML encoding for developers. A lot of modern frameworks backend frameworks does encoding by default, like templates, or common kind of XSS encoding, like Django, Rails, Mustache for Node.js. They're generally secured by default, unless you want to do something fancy. So back in the days, you have to opt into HTML encoding. Now, if you're actually using a modern framework, check, but normally all outputs are encoded by default. You have to opt, it's on an opt-out basis. And there are some exceptions, like for example, oh, hold up, one moment. So for front-end framework, like React or Angular, once again, HTML encoding is done by default if you're using user-supplied input. If you really don't want your data to be HTML encoded, there is a method in React, and it's actually just called dangerouslySetinnerHTML. It's like you have to render your content with that method in order to render raw HTML. And it doesn't even take a string. It takes, I think, an HTML object that has a HTML string field to it. So you really got to know what you're doing before you actually use this method. But once again, bear in mind, this is HTML encoding. So yeah, it's a pretty awesome method name. It's like, are you sure you want to shoot yourself in the foot? And you're like, yeah, I know what I'm doing. So if you don't have access to any templating engine, or if you're not actually using any front-end framework, and you still want to do server-side HTML encoding, don't write your own. Use a well-established library. If you're using .NET, there's a method in HTTP utility just called HTML encode. Pass in a string, it spits out save string, HTML encoded string. In Java, there's a method in string escape utilities. Yeah, And pretty much if you're using, say, Node.js, search for HTML encoding, you're going to find a lot of libraries. Because it's Node, there's probably like a library for everything. So, demo time again. We HTML encoded everything. Life is good. Let's demo time again. We're safe, right? Life is good. So, next example. Because I'm lazy, it's an export. So, please sign my improved guest book. Felix, this is good. There we go. All right, so it looks the same. Life is good. Let's change the title to script alert 1. This is what happens. You notice the angle brackets gets displayed on the page, as opposed to the familiar bam alert box popping up. You're like, okay, understandable. What happens if we put it down here? Whoa, what just happened? This is good. Script alert 1. Let's try that again. Let's put it in the message section. We scroll down. This is good. So everything is HTML encoded. Any ideas on how to exploit this? I'm looking at the guy in the KiwiCon t-shirt. He looks like he knows what's going on here.
Is it called breakouts?
Pardon?
Is there some technique called breakout?
Oh, I forgot to give you one piece of important information. So, when you float your mouse over an image, okay, it's not working in this, but alt text uses your username. So, for example, in here, when you float your mouse over the image, for browsers that can't display images, the mouse over text is your username. See, for example, in this case, it says Alice. In this case, it says Bob. Any ideas so far? No? You can't cheat. You heard this talk before. You can't cheat.
Close the alt tag and then start your own.
Exactly. So, for example, what if we have something like this? So, image source is blog. Alt is username. That is what it looks like so far. So, whoa, what on earth is this?
Some key combination.
Some key combination. Yep. And what if the username is, like you said, close alt tag, and then just say on mouse over or unload, for example, equals, let's say alert 1. And then what we need to do is that we just have to deal with the lingering quote mark, because if we copy this and we paste that in here, we get something like this. So the alt text is empty, and then we float and then we added a JavaScript event handler called onMouseOver. And then we sorted out the lingering quote mark by just adding in some arbitrary attribute, so it doesn't give me a parsing error. So, you know what, let's try that. So the reason I'm using onMouseOver is that so I have control over when the JavaScript gets executed, because if I change it to unload, every time I load the page, it gets run, and it gets really, really annoying. So let's try that. Where am I? I'm here. Copy. All right, let's go down here. So that's the username. And I float my mouse over it. This happens. So JavaScript can still get executed. So now, if we have someone evil, we can change that to unload. What was the thing we did earlier? Something window location, something I can't remember on top of my head. Oh, the URL I used. There we go. That's the URL I used. One moment.
I think you can just set the location.
Oh, okay. I normally just use window location, but nope, that definitely works. Also unload window.location equals what was it? POC. There we go. This one. Let's change it to this. See if it works. All right, so let's try that. So every time that image loads, it gets redirected to the dodgy login screen. Yeah, that should work.
5,000?
Right, pardon?
It looks like you're on the 5,000 port. Oh, maybe you're on 5,000.
No, I should be on 5001. You're absolutely correct. Good spotting. Yep. So, see if this works. Now, in caps. There we go. So now if I... You get the idea. All right, so we HTML encoded everything. Oh no, why is it still an issue? There we go. So as I mentioned earlier, the alt text for the image, user can still supply stuff in there. But you're like, all right, all this stuff's already HTML encoded. You know, spiky brackets are getting turned into safe characters. Why are they still getting executed? And then you realize, for this attack to work, well, you don't actually need spiky brackets, just quote marks. The user supplied data is being used in a different context. So, for example, in this case, if people can manage to break out of the quote mark area, they can just add whatever attribute they like. So let's talk about encoding again. So this time the user-defined data was actually used inside an HTML attribute. There are other places where user-defined data can get used in an attribute. For example, if your application have as a user profile section where they can fill in the username, the email address, and they click the edit button, and all the text box gets filled out by the server. In this case, the user data gets filled into the value field. Alternatively, if the user have control over the image source, they can put whatever the hell they like in there as well. Another flavor of encoding, generally called attribute encoding. So that encodes two things in particular and some other ones. So apostrophe and quote marks. So it turns them into, once again, literal characters. So in this case, once we have applied attribute encoding in this field, you notice it turned the apostrophe. Otherwise, they would have actually escaped out of this field into just ampersand #39 semicolon, which safe to be displayed. So if you're using a templating engine like Django, Rails, whatever templating engine flavor of the day is, a common defense against that is to wrap your user input in quotes, actual double quotes. That tells the templating engine, right, this is a user input field. We will escape all the quote characters in there, which is kind of strange. And for the devs that doesn't have access to templating engine, once again, use an established library, HTML attribute encode for .NET or for HTML attribute encode in Java. And for Node, look at NPM. There's probably some bajillions of libraries out there because it's Node. So earlier on the slide, I think earlier on the presentation, I mentioned XSS is still a thing. And that is why why is it so hard to defend against? And that is why it's difficult. Because user-supplied input can be used in so many different contexts. It can be displayed in HTML, it can be displayed, like say, inside an HTML attribute. It can even be used inside JavaScript. So for example, you've seen those three. You've seen it being displayed inside the HTML body. You've seen it inside an attribute. You've seen it being used inside URL parameter. But there are other places as well, like user-supplied input can be used inside a script tag. In that case, perhaps one or many escaping mechanisms must be used. But we don't see this very much now. But a few years ago, putting user-supplied input in cascading style sheet, you can actually execute JavaScript in there as well. It used to be an issue. I haven't seen it in a while. Maybe other people have, but I personally have not. And some others. And sometimes you need to use multiple types of encoding. For example, in this case, what kind of encoding would you use here? Would you escape apostrophe and quote marks, or would you apply HTML encoding to this?
What's the harm in applying all of the different encoding schemes?
That is a very good question. I will get back to you on that one. The question is, what is the harm in applying all the encoding schemes? So in here, in some contexts, for example, in the HTML encoding one, you notice it turns control characters like spiky brackets and whatnot into ampersand, hash, something else, right? If you display that in a non-HTML context, it's going to get displayed as that verbatim. So it's going to look very ugly. For example, if you store HTML encoded stuff inside a database, and then you pull that user database, you pull stuff out of that database, and you render it on a mobile native client. You see it's like not a web view, but actually just render it on, let's say, Android or iOS. It's going to get displayed as ampersand, hash, something, something, unless you explicitly HTML decode it. Do you see what I mean? Yeah. So sometimes it's just aesthetics. But in this case, if you go, right, I will escape apostrophe and speech marks. So you're like, that's good. But you notice that's not being escaped. That part is not. The /script part. So that terminates the script tag, and then someone else can start a new script tag. So that prevents the first alert 1, 2, 3 from being executed, but it does not prevent the alert 1 from getting run. So, more ways to prevent XSS. When applicable, input validation. Should you really allow special characters in some fields like usernames? Should you really allow greater or lesser characters in usernames? And a lot of people say, right, can I just blacklist those characters? People find ways around it. Generally, when applicable, everyone's familiar with the term whitelist versus blacklisting? So whitelist is when you provide a list of characters that you're allowed to be displayed. Blacklist is, hi.
Going back to a previous example of kanji characters.
Yes. Kanji characters.
Again, like Cyrillic, Greek, Hebrew, how big should whitelist going to be at that point?
That's why sometimes input validation can be very difficult. The question is, what if there's a lot of, you support a lot of languages like Hebrew, Greek, etc. Yeah, so you can have a really large whitelist, or you can choose to opt out for another approach.
Are there any pre-existing Unicode whitelists which encompass most currently used?
Yep, I believe most common libraries or frameworks contains so-called.
Right.
Yeah, those whitelists. Reject fields that have failed validation. If possible, don't try to sanitize it yourself, because there's a matter of data integrity as well, in the sense that you are modifying user-provided data. And if you are doing input validation, make sure you are using it consistently throughout all the areas where that user-provided data can be changed. Let's say, for example, if you are doing input validation on username, on sign-up, but you also have a user profile section where you can edit the username, there's no point of putting input validation on the username on sign-up and not putting it on the edit user profile page, because people can sign up with benign characters, and then they go to edit my name, I'll change my name to something else. If you're using validation, ensure that you're applying it consistently throughout all points where that data can be modified. Another thing, special mention for user-defined URLs. So if you're building if you're building a user profile page and user can say, hey, visit my home page, special mention. If people can actually put URLs that starts with JavaScript : when people click on that URL, they can run JavaScript. Because normally with URL, you always see it's starting with HTTP : or HTTPS : something. But if you put, say, JavaScript : and you can just put JavaScript behind it, when someone clicks on that link, it will run that JavaScript in their browser. Which is always an interesting case. For example, you're like, oh, visit my browser. It's JavaScript : window.load. Yes.
For what it's worth, I managed to do that recently and just copied form that's on the application I was working on, just to prove the point, copied the form that is on another page of the site for deleting your account.
Yep.
And when you click this link, oh, look, learn more about Wellington, deleted your account.
Well, that's one way to learn more about Wellington.
It's quite fun.
Hmm.
Didn't stop it.
Yep. Yeah, validation strategy. You can always fail the validation if it starts with JavaScript. Validate that the data is a valid URL. Most libraries and frameworks, you can actually just take a string and construct a URL object out of it. And then from that, you can do analysis on the URL object. And optionally, check if the URL is on a blacklist, if you're really worried about scammers and just people putting malware using your, say, application as a malware distribution platform. Cookie security flags. So previously we mentioned with JavaScript, you can access the user's cookies. If people can steal your cookies, they normally steal your session. There are some flags you can set to protect your precious, precious cookies. There are two flags here right now, which I personally recommend. One of them is called HTTP only. It means that once the page is loaded, you can't access the cookie-based JavaScript. If you open up the JavaScript console and you go document.cookie, this doesn't show up there. So the browser has access to it, JavaScript doesn't. The next one is just called secure, which means your precious cookie can't be sent to a non-HTTPS context. So you can't be sent over plain text HTTP. With those two in place, it can be very difficult for rogue JavaScript who just goes, all right, I would like to exfiltrate your cookie from this domain. But that doesn't mean that they can't do other things to the affected user's account. CSP is a bit out of scope for this one. This is another, yes.
Does the secure flag mean that that it won't be able to transfer to a new HTTPS?
They can be sent. The question is, does secure mean they cannot be sent to a new HTTPS domain? And the answer is, it can still be sent to another HTTPS domain. So with the modern, with Let's Encrypt, anyone can register one. So yes.
Right.
There we go.
But it has to have the same domain name or subdomain. So it won't go to a third party domain.
I thought that was for third parties, like content balances, they're balancing content delivery networks.
We'll get to that. So something else. So CSP. If you're interested, this is a very good but difficult way to prevent XSS, especially if you're working with legacy code base. So what that is that it pretty much sets a series of HTTP headers and says, we won't allow inline JavaScript done, or inline JavaScript can't get executed on this domain. Alternatively, there's stuff like, we won't allow execution of JavaScript files that are not signed with a certain hash. For example, like an attack, if they inject JavaScript code, if they're not verified, they can't get executed. So if you're working on legacy code, a lot of the stuff like inline scripts are everywhere, and you're including a lot of JavaScript as well. So, but if you're building a new product, hi.
I was just going to say that with this thing, it's, as you say, it's really good.
It's good.
A bit difficult. But often the weak point is not your side, it's the vendors you're integrating with that drop scripts into your site. You have to load. And if you turn off inline scripting, maybe you can turn off your site, but you can't always guarantee it's going to still keep those vendor scripts down.
Absolutely. And especially if you are linking your site with, say, data analytics JavaScript and what's not, you have a choice of either hosting the JavaScript on your own domain, or somehow, in that case, if you're hosting it by yourself, you need to update it constantly, and that's just another thing to worry about. Yeah. So, but there are some ways that can make it a lot easier. So there's actually a talk done by the Google guys called, so we broke all the CSPs, that was at OWASP Day, New Zealand. So they talked about a new keyword, just called, not a new one, it was a new keyword called strict dynamic, I believe, which is just another way to actually make CSP work with some of the legacy systems or third-party JavaScript.
So what do you think about projects like Google's AMP in terms of web security, in terms of enforcing their practice? Because you're not allowed to run third-party JavaScript unless you're in certain contexts. Maybe it's a useful thing.
No, I agree. I think it's actually very useful, but actually doing it right, or especially supporting large infrastructure. Sometimes I think I'm not sure how feasible it is given limited time and resource. I mean, not every one of us here is from Google, or have the amount of time and resource like Google. So,
I forgot. Sorry.
oh good, carry on. I'm nearly done, so it's okay. You don't have to sit there for too much longer. Some people are dozing off. So, yep. So, takeaway message: developers, know your app. It's an old meme. How old is it? Like a few years old. Yeah. So yeah, know your app. I mean, it sounds really stupid, but actually know where your user data gets used, know where their input points are, know where they get displayed, and from there on, you can actually start testing it. Know the limitations of your framework, your front-end framework, your back-end framework. Know pretty much where your data is being encoded or escaped. Validate input when appropriate. Use security flags when appropriate. Use content security policy.
I seem to remember there's a upcoming new HTTP header, which is going to help avoid XSS.
Which one might that be?
I cannot remember. I was trying to Google it before. I can't remember. But this one, it's not yet fully implemented, or possibly in version. It's upcoming.
Okay.
So it might help.
Ooh. Quickly on that one, during pizza. So, any QAs here? Oh, good. All right, let's skip the slide. No, actually, who am I kidding? Yeah, so testers, if you actually want to test for stuff, take off the page that contains user data, and there's plenty of word lists out there. If you just search for XSS test payload, there's plenty of them. And if you're not already, use a proxy. For example, Zap's free. And there's a free version of Burp. I'm actually a personal fan of Burp. Even the free version is actually quite good. There's also Charles or Fiddler. Ask your security team for guidance and automate when possible. Try to integrate some basic security testing in if you're using a continuous integration or continuous deployment pipeline, see where you can actually slot some security testing in there when applicable. Some useful links. Would you like to know more for XSS, QAs, CSP, proxies, and if you want to if you want to play around with cross-site scripting in a controlled environment, there are some sandboxes out there where you can just go on the website, and then it's like a mini game. There's multiple levels. Your goal is to get alert 1 to display. I'll share the slides afterwards, so you don't have to take me notes. Yeah, and there, just shout out to this cool piece of tool called Beef. How many of you guys have actually heard of it or played with it in the past? Beef, so it's called Beef. It stands for Browser Exploitation Framework, I think. Yep, great, I'm butchering it pretty good. So what it does is it just checks a piece of JavaScript on the page, and it actually shows you how powerful XSS can actually be. So it pretty much can do anything the user can do, ranging from displaying an image, key logging, access like play sound, play music, ask the user access to say the webcam. No, you can actually do a lot of stuff. It's open source. Everyone have a look, play with it. And if you work in the security team in the company, if you want to scare someone or just have some fun, run that as a demo. If you're like, oh, this is cross-site scripting, it's just alert 1, it's not a high priority issue. It's like, hey, look at this, look what I can do here. It's a cool demo. All right, cheers. That's me. And have an awesome evening.
Does anyone have any questions for Felix? Yes.
Yeah, just something to follow up on that JavaScript inside a tag, inside a link. Right? Does that count as inline JavaScript for a CSP?
So for JavaScript inside?
Yeah, inside a link. Does that count as inline? Would that CSP stop it from running if you click it or not?
I don't believe so, but don't quote me on that one. I don't know. No, I don't know. Not on my head. Yep.
Can you get XSS in something other than HTML? Like, say, if you're rendering a PDF as part of like a report or something, can you have XSS inside that PDF?
Yes, you can. I'm glad you asked. So you can, in fact, have XSS. So some PDF reader supports JavaScript because. So I think Actually, this is being recorded, so I'm not going to name any names, but some PDF readers, like if you actually navigate around the PDFs, actually use JavaScript anchors, so you can actually, in fact, include XSS inside PDF. It's just based on what reader you use.
Are there libraries to filter that out? So, like, if you've got a PDF, if you're rendering a PDF, can I pass user input through some sort of library that goes, okay, we need to render this XSS in the context of a PDF. So we need to filter the XSS in context of the PDF.
I don't actually know. Sorry, I haven't actually looked into the PDF context that much. Terribly sorry. Lately, I've been playing around with the framework called Electron. You never heard of it? Yeah. So pretty much what it does is it turns HTML5 web apps into desktop applications. If you get cross-site scripting in that kind of context, you have access to the Electron API. Can you run operating system commands? I don't know. I haven't actually successfully.
The last KiwiCons talk about some chat application which is based on Electron, and someone found it.
That's right. Yeah. Yeah. So yeah, I don't know. I thought it'd be cool. So XSS not only strictly browser-based. When you run JavaScript, there's a chance you get XSS.
This is why I don't do front-end development.
Yeah, that's cool. Front-end dev is cool. All right.
Okay. Do we have any vegetarians in the room? There's some vegetable-based pizza there. Cheese only. Yeah. And otherwise, the soft drink in the fridge. And on the table there, so please help yourself. Looks like an over-catered pizza again, so that's good for us. Eat as much as you can. Cool. Let's just clap for Felix again.
I left the hangout. Have you stopped the recording?